I'm Anil Kumar sharing with you a test paper on derivatives of function. It will help you to prepare for your test. We have 6 questions here. You can always pause the video, copy these questions, and then look into my suggestions. The first question, we have a variety of functions for which you need to find derivatives using power rule, product rule, and this is modified power rule. Then the question is, find the points where the tangent to the curve is horizontal. Now horizontal means derivative is 0, right? Then here's a thinking question. Given f of 3 equals to 2, g of 3 equals to 4, derivative of f at 3 is 5, derivative of product of function f and g at 3 is 30, you need to find what derivative of function g is at 3, correct? So that's what you need to figure out. Then the next question here is, determine equation of the tangents to the curve y equals to 2x squared plus 3 that pass through the point 2, 3. Now it's important to understand whenever we write tangents, equations and tangents, then that point may not be on the function. So we are trying to find equation of tangents from an external point. Only then you can have more than one tangent, correct? The last question here is, position s in meters of an object moving in a straight line is given by s equals to t times 6 minus 3t to the power of 4, where t is greater than or equal to 0. Where t is time in seconds, determine the time when the object is stationary. When we say that the object is stationary, it means velocity is equal to 0. Now with that, I think it should not be very difficult to solve these questions. You can always pause the video, answer, and then look into my suggestions. Now let's take these questions one by one. We need to find derivative of following using power rule. So we have two functions here. F of x equals to cube root of x squared plus square root 2 times x to the power of square root 2. So let's begin with this one. As you know, the power rule is that if we are given y equals to x to the power of n, let's say k times x to the power of n, then the derivative of this function is k times n times x to the power of n minus 1. So that is the power rule which will be applied to solve both these. So f of x equals to cube root of x squared. Since it's easier to write n as a rational number, we'll change this from radical to the exponent form. So let's rewrite the equation first. So we get f of x equals to x to the power of 2 over 3 plus square root of 2 x to the power of square root of 2. Now the derivative of this function is, power is 2 over 3, so it comes 2 over 3 here, x to the power of 2 over 3 minus 1. Now here we get plus k, the constant is square root 2, x to the power of square root 2, that means it gets multiplied by square root 2, and x to the power of square root 2 minus 1, correct? Now this gives us 2 over 3, 2 minus 3 is minus 1, so we get x to the power of minus 1 over 3. Now that gives us 2, square root 2 times square root 2, and x to the power of square root 2 minus 1. Now it is good practice to write this with positive powers. So we should write this as 2 over 3, and that is cube root of x, plus 2 times x to the power of square root 2 minus 1, right? So that is how we can write derivative. Now in the second question, purposely we have given product but mentioned power rule to be applied. That means you have to open this bracket, correct? So you have to open the bracket. So once you open the bracket, you get 2x to the power of what? We are adding half to 3 by 2, right? So it is kind of like this. 3 by 2 plus half plus 3 times x to the power of 1 over 3 plus half, right? 1 over 3 plus half. So let's simplify this. We get 2x to the power of 4 divided by 2, right? 4 divided by 2 is 2, so it's square, plus 3 times x to the power of, here the denominator becomes 6. 2 plus 3 is 5, 5 over 6, correct? Now the derivative of this function can be written as 2 times 2, application of power rule, x plus 3 times 5 over 6 times x to the power of 5 over 6 minus 1, which is 4x. Simplify this to get 5 over 2, x to the power of minus 1 over 6, which is 4x plus 5 over 2 times 6th root of x, right? So 6th root of x. So that becomes the solution or derivative of the second function, correct? Let's move on to more examples. Find derivative using power. Find derivative using power rule of f of x equals to all this. So in this, as we did last time, take it as a practice question, open the brackets, and then solve. So we could write this as x to the power of 1 over 3 times 3x minus 5x to the power of 4, right? So when you open the bracket, you get 3, x to the power of 1 plus 1 over 3 minus 5 times x to the power of 4 plus 1 over 3, right? So that is 3 x to the power of 3 plus 1 is 4, so it's 4 over 3 minus 5 x to the power of 4 times 3 is 12 plus 1, 13 over 3. Now we can apply the power rule. So we get what? 3 times 4 over 3 x to the power of 4 over 3 minus 1. And here we get 5 times 13 over 3 x to the power of 13 over 3 minus 1. So that is 4 x to the power of 4 minus 3 is 1. So we get 1 over 3 minus, we can just multiply this. 5 times 3 is 15, 1. 65 over 3 x to the power of 13 minus 1 is 10, 10 over 3, right? So that becomes the answer. You could write in radical form for cube root of x, since the question has radical form here, but it's kind of mixed. So anyway, let's write the radical form. So we have cube root of x to the power of 10. So that is how it could be done, right? Next question here is, we need to apply the product rule, but we are given in the quotient form. So we can rewrite this question as f of x equals to 2 minus 3x times x squared minus 1. Now the product rule is, if we have y equals to u times v, then the derivative is derivative of u times v plus u times v derivative, correct? So we can write this as derivative of f of x as equal to, let me write in this form, d dx of 2 minus 3x times x squared minus 1 plus 2 minus 3x times d dx of x squared minus 1. Now derivative of the first part is minus 3, that times x squared minus 1 plus we have 2 minus 3x times derivative of the second part, which is x squared minus 1, is 2x. We can expand and simplify. So we get minus 3x squared plus 3, and here we get plus 2x times 2 is 4x minus 6x squared. So combining these terms, we get minus 9x squared plus 4x plus 3. So that becomes the derivative for the given function, right? The next function here is find derivative using power function rule. F of x is given to us. Now, here we have to multiply by the derivative of inside function, right? So we could write this as derivative of this function as 3 times. So we are applying the power rule first, which is x squared minus 3x plus 1 whole square times derivative of inside function, which is x squared minus 3x plus 1, correct? So we get 3 times x squared minus 3x plus 1 whole square, and that derivative is 2x minus 3. So if nothing is mentioned to simplify, we can leave in this way, right? So that becomes the derivative. Okay, so we have one more of the similar kind. We'll find derivative of this function using product rule. So we could write f of x as derivative of the first function. Let me write in full form. Derivative 1 minus x squared to the power of 4 times 2x minus 1 whole cube plus first function, which is 1 plus x squared to the power of 4 times derivative of the second function, which is 2x minus 1 whole cube, correct? Now, here we'll apply the power function rule. So derivative will be 4 times this function, which is 4 times 1 minus x squared times derivative of inside function. So we have to multiply by the derivative of inside function, which is minus 2x. And then we'll multiply by rest of the terms, which is 2x minus 1 whole cube. Now let's get to the next function. Okay, this is cube, I missed it, sorry. So 4 times function to the power of 3, that becomes the power rule, and then the function's derivative should be multiplied with. Here we get 1 plus x squared to the power of 4, and this derivative will be 3 times 2x minus 1 times the derivative of inside function, which is 2, right? So we can multiply these terms and simplify this a bit. So we get minus 8x 1 minus x squared whole cube times 2x minus 1 whole cube plus 3 times 1, well, this should be minus, by mistake I wrote this should be minus 1 minus x squared to the power of 4, that's the function, right? Times 2x minus 1. Now this also 3 times 2x minus 1 whole square, I missed that also. And 2 times 3 is 6, let me make this 6, okay. So that is what you get. Let's recheck. So something to the power of 4 will be 4 times something cubed times the derivative of inside function. Copy this as such. This is 1 minus x squared to the power of 4, derivative of the second function, which is 3 times 2x minus 1 whole square times 2. Right. 4 times 2 is 8, that is correct. Now at times you could simplify this. Between 8 and 6, we have 2 as a common factor. So we could take plus or minus. Let me take minus 2 as a common factor. Now we don't have any x, so we'll just keep it. As far as the powers are concerned, 1 minus x squared cube is common and 2x minus 1 square is common, correct? So we're left with 8 divided by 2 as 4, x, and amongst these powers we have 2x minus 1. Here we are left with negative, positive divided by negative, 3 times 1 minus x squared, correct? This is already taken care of. Now we could simplify this portion. We get minus 2, 1 minus x squared whole cube times 2x minus 1 whole square. And let's open this. 4x times 2x is 8x squared minus 4x minus 3 plus 3x squared. So that gives us minus 2, 1 minus x square whole cube times 2x minus 1 whole square times 8 plus 3 is 11 minus 4x minus 3, right? So that is a simpler form to leave the expression at. So that becomes the derivative of the function. This is all derivative of the function, right? Okay, so let's move forward. Do the next question here. So now we are into kind of word problems. The question here is, find the points where the tangent to the curve y equals to 2 times x minus 29 times x plus 1 is horizontal. So horizontal means derivative is 0. So that means we are looking for y dash equals to 0, right? So let's find the derivative of the function. We are given y equals to 2 times x minus 29 times x plus 1. We can apply the product rule here. So we have dy dx equals to, 2 is a constant, so just keep it outside, right? Now we could do derivative of the first function, let's say d dx of x minus 29 times x plus 1 plus the first function x minus 29 times derivative of the second function, which is x plus 1, correct? So that gives us 2 times derivative of the first function is 1, so we are left with x plus 1 here, plus x minus 29 times derivative of this function is also 1. Okay, so that gives us 2 times x plus x is 2x, and 1 minus 29 is minus 28. You could take 2 common, so you get 4 times x minus 14. Now we want this derivative to be 0 for horizontal, right? We want to find points where the tangent to the curve is horizontal. So horizontal tangent means what? Means slope or dy dx equals to 0, right? So we'll equate 0 to the slope which we found, which is 4 times x minus 14. So clearly it is 0 for x equals to 14, right? So we get our point with x value as 14. We have to find the y value also. So for x equals to 14, we'll substitute this back and find y equals to 2 times 14 minus 29 times 14 plus 1, right? Which is 2 times minus, this is 15 times 15. Okay, so that is minus 30 times 15. 3 times 5 is 15, 450, correct? So we get minus 450 as the y coordinate, and therefore our answer is that the coordinate points are 14 minus 450. So at this point on the function, the tangent to the curve will be horizontal, right? So that is how we can find. So we have only one point in this case which will have horizontal tangent. Okay. That is the vertex of this parabola also, correct? Okay. Now let's look into the second question, which is a thinking and application question. We are given f of 3 equals to 2, g of 3 equals to 4, derivative at 3 is 5, derivative of product of function at 3 is 30. We need to find derivative of g at 3, correct? So what are we given here is also the derivative of the function. So when I say f times g, right, derivative at 3, that should be equals to derivative of f at 3 times the value of function at 3 for g plus f of 3 times derivative of g at 3, right? Now we are given this derivative, so let's equate that part. Left side is 30. Now f dash 3 is 5 for us, we'll write 5 here. G3 is given to us as 4, so this is 5 and this is 4 for us, plus f of 3 is 2, and this is what we need to find. So let's put G dash 3 here. So now we can rearrange. So you got 30 equals to 5 times 4 is 20, plus 2 times G dash of 3. Let's do 30 minus 20 equals to 2 times G dash of 3, and that is 10 equals to 2 times G dash of 3, or 10 divided by 2 is the derivative of G at 3, and clearly this is equals to 5. So our answer is the derivative of function G at 3 is equal to 5, right? So this is a very interesting question and I hope you appreciate it. Now we have to find equation of the tangents to the curve y equals to 2x squared plus 3 that pass through the point 2, 3. Now if I substitute 2 here, what do I get? 2 square is 4, 4 times 2 is 8, I get 8 plus 3, 11, I don't get 3, right? Whatever I substitute for x except 0, I don't get 3, perfect? So what we have here is a parabola, and clearly at 0 it is 3, right? So at 0 it is 3. Okay, now and a point which is 2, 3, so somewhere outside. So from that point we have to find equations. If we have a point outside the curve, then actually you could have 2 tangents. So we'll just draw 2 tangents, right? Not bothering where the points are. Both y values of 3 do indicate that they are horizontally placed, but I'm not doing it, right? We are just trying to figure out a general solution. We say this is the point 2, 3 for us, external to the curve, and that's the curve. Now let us assume that the point on the curve where we have a tangent from external point 2, 3 is at x equals to a. So this point will be a and the y value will be f of a, correct? So that becomes the coordinate. So clearly, what is f of a equals to? F of a is 2a square plus 3. So that is 2a square plus 3. So at a, on the curve, any point in general will be 2a square plus 3. Now, what is the derivative of y equals to 2x square plus 3? Derivative is 4x. That means slope of the tangent line at any point is 4 times x. So at a, derivative will be, at x equals to a, it will be 4a, correct? So this is one way of finding derivative. The other way is, we could always write rise over run, correct? So the alternate method here to find derivative is that slope m is y2 minus y1 over x2 minus x1. So in our case, y2 is this value, which is this value. So we could do 2a square plus 3 minus 3 over x values a minus 2. So we get slope between these 2 points. We can call these points as, let us say, P and Q. So slope PQ is that. And also 4a. So we can equate it, right? So this could be simplified as 2a square over a minus 2. Now both these slopes are at a point A, right? So that means y dash at x equals to a should be equals to mpq, right? So that gives us an equation to solve. So we get here 4a equals to 2a square over a minus 2. Perfect. Since it is at the same point, 2 slopes, both should be same, right? So now we can cross multiply. So we have 4a times a minus 2 equals to 2a square. So that is 4a square minus 8a equals to 2a square. Bringing that together, we get 4a square minus 2a square minus 8a equals to 0. Now we can solve for a. So which is 2a square minus 8a equals to 0. Factoring 2a will give us a minus 4 equals to 0. That means a equals to 0 or a equals to 4. So we get two values of a. Now, if a is 0, what is f of 0? F of 0 is 3. So if a is 0, we have f of 0 equals to 3. So we have 1 point. And if a is 4, then what is f of 4 equals to? Substitute 4 here. 4 square, 16 times 2, 32, plus 3, 35. Got it? So what we did was, we substituted 4 here. So f of 4 is 2 times 4 square plus 3. 4 square is 16, times 2 is 32, plus 3 is 35. Got it? So we got 2 points. So basically we got these 2 points. So one of the point for us is, let me write down here. So we have 2 points. So we'll call them as Q and R. So point Q for us is, let us say, a value of 0 and y value of 3. So 0 and 3. And R for us is 4 and 35. Now slope is given by this expression. Y dash is 4 times x value. So slope m in this case is 4 times 0 is 0. And in this case, slope is 4 times 4, which is 16. Perfect. So we have 2 different lines. So these are the tangent lines. Now 0, 3 is the y-intercept, slope is 0. So the equation for this line is y equals to 3, or you can write y minus 3 equals to 0, either way. In this case, we could write slope as 16. So y equals to 16x plus b. To find the value of b, let me substitute 4 and 35. So 35 equals to 16 times 4 plus b. Or we could do 35 minus 16 times 4. 4 times 6, 24, 2, 64 equals to b. Or the value of b is equals to, now that is a negative value. 14 take away 9, 5 is 9, borrowed 1, so it is 29. Correct? And therefore, the second equation is y equals to 16x minus 29. So these are the 2 equations of tangents to the curve. Perfect. So we can write down our answer that the equations to the tangents to that curve that pass through the point 2, 3 are y equals to 3 and y equals to 16x minus 29. Perfect. So that is how this kind of question can be solved. So have a good look at it, and then we'll take up the next question. I'm Anil Kumar, and here is a bonus question on derivatives of functions. The question here is, the position s in meters of an object moving in a straight line is given by s equals to t times 6 minus 3t to the power of 4, where t is greater than or equal to 0, where t is time in seconds. Determine the time when the object is stationary. So we are given the displacement function s of t basically, which is t times 6 minus 3t to the power of 4, and t will be greater than or equal to 0. Stationary object means 0 velocity, right? So let's first find rate of change of displacement. So rate of change of displacement is velocity. Here we can apply the product rule. Derivative of t is 1, so we get 6 minus 3t to the power of 4, 1 times this, plus t times derivative of this function. So 4 times, we'll apply the power rule for the functions. 6 minus 3t cube times derivative of inside function, which is minus 3. Perfect. Now, let's rewrite this. 6 minus 3t to the power of 4 minus 4 times 3 is 12t, 6 minus 3t whole cube. You can take 6 minus 3t whole cube common. That gives you 6 minus 3t, and here you get minus 12t. Perfect. And what are we getting on this side? Derivative is velocity, right? So we are getting velocity, and for stationary velocity, this has to be 0. Remember that. So we could write this as 6 minus 3t whole cube, and here we get 6 minus 15t. Minus 3 and minus 12 is 15t. Now for this to be stationary, this velocity should be 0. This is for stationary object, right? So we want stationary object. Not moving, that means not moving. So velocity is 0. Now these two factors could be 0 for, so first one, 6 minus 3t equals to 0, means that t is equals to 6 divided by 3 or 2. So that is one value. The other one to be 0 is 6 minus 15t equals to 0, means 15t equals to 6. So now it can be solved. T equals to 6 over 15, right? So these are the two times. Time is given in seconds. So the answer is t equals to 2 seconds or t equals to 6 over 15 seconds for the object to be stationary, right? So with this we come to an end of this set of questions which will help you prepare for quiz on derivatives. Take it as a mid-chapter review. Since we have only learned half of the things, we know the derivatives of power rule and the product rule. And these are good examples to practice for your test. All the best. Feel free to share your views. And if you like and subscribe my videos, that'd be great. Thank you and all the best.